morning, guys. Here back for the second week of physical science with our virtual school stuff. Gonna post a video today. We're kind of shift gears. We in physical science have basically covered most of the stuff we need to cover in chemistry. On the chemistry side of things, there were a couple things that we didn't get to in the first semester that I want to get to now over the next 4 weeks or so that have to do with waves and electricity. So we're going to kind of shift gears. This is what we would have done with you guys had you been here. We would obviously have taken a test. It would have taken a little bit longer. And maybe a couple of extra little things in chemistry we could have done, but maybe one or two things that we just can't cover with you without having you here in class when it comes to acids and bases and those type of things. I'll try to figure out a way to get some of that stuff on there for you, just to give you, so you can see it a little bit. But we're going to shift directions. Like I said, we're going to talk about waves, okay? This video will be very short today. It's only 6 or 7 slides at the most, and I do have an assignment for you that you need to do. On that assignment, you can use the internet to help you answer the questions that go along with it. There will be websites that are attached to it to help you answer those questions for waves and the Wave Web Quest. And if you do not have access to the internet, you can do your own research to help you find these answers. You can come across something to help you find these answers, which will not be very hard. But as we begin to talk about waves, and some of this will answer our questions also. As we begin to talk about waves, what is a wave? A wave is a disturbance that carries energy through matter or space. So when we think about waves, a lot of times you guys just probably think about water waves. But as you hear me right now, you know those are called sound waves. You see in this classroom, we see the light waves, radio waves, you have infrared waves, you have all these different waves. You have waves that are really, really short, you have waves that are really, really long. We talk about short waves. Short waves will be gamma waves, and those gamma waves carry we'll talk later on about amplitude and frequency, we'll talk more about that next week, but they carry very, very, very large volumes of amplitude because they carry a lot of energy. All right, so they're really, really short, really, really compact. Some of the longer waves are radio waves, and that's why we're able to turn the radio on, drive down the car, and able to hear radios. Radio waves can travel the lengths of mountain ranges. Radio waves can be super, super long. You have microwaves. Talk a little bit about microwaves as we go through this. So they carry, like it says there, a disturbance that carries energy through matter or through space. So they can travel through matter or space and we don't see them. Most waves travel through a medium. So the sound waves, the medium, the sound wave that's traveling to you right now through the camera, that medium itself is the air around you. The light waves, all right, they don't have to pass that medium. That light can always be there. The matter through which a wave travels is called that medium, okay? Waves that require a medium are called mechanical waves. So if they require a medium, they have to be mechanical. Sometimes they don't always have to be mechanical waves. The next thing, a light does not require one. So like we said, this light, when you think of space, okay, in space there is no medium for anything to travel through, but yet we still see the light. Think of like the stars at night. When you look up at the Milky Way, you see the galaxies, you see all the different stars. You can see that light coming through you, but yet that light is traveling through space and nothing there's just emptiness there. So that light can travel through it. Light waves consist of changing electric and magnetic fields in space. You're going to see that on some of these questions you're going to have to answer today that go along with your assignment. So these light waves consist of changing electric and magnetic field in space. So they're constantly giving off electrons, and those electrons are constantly interacting with those protons, and that's why it's able to travel throughout without a medium. Light waves are also called electromagnetic waves. We think about electromagnetic waves. Think about the electromagnetic spectrum. Electromagnetic spectrum, Roy G. Biv, red, orange, yellow, green, blue, indigo, and violet. Those are the different colors that we see, the different light colors that the human eye can detect. Outside of that electromagnetic spectrum, Roy G. Biv, think of red, infrared is on this side of it, all right? All the way through violet. Green, red, orange, yellow, blue, green, indigo, and violet. So the purple side, we have some different types of waves that are on this side. The electromagnetic spectrum is where we hang out. It's what us as humans, it's all the different colors that we see. Waves transfer energy. Okay, you think about a water wave. You think about the amount of energy that that wave is going to carry. Think about a sound wave. When we have really, really high-pitched volumes of sound, it can hurt our ears. Especially think about like your dog. All right, your dog can hear an ambulance from a long ways off because he can hear it because he has better hearing than us. But they begin to bark and do those kind of things because that high pitch of the ambulance that it's putting off hurts their ears. So it's carrying that energy. Low pitched sounds, real dull, can harm human ears also. And it's sounds and it's these waves of sound can be so high in frequency and so high in pitch that we don't hear them, or so low that we don't hear them, but yet it's going to harm, and it can harm our eardrums when it comes to waves and these things transferring energy. Energy may spread out as the wave travels, so we're going to lose energy. Think about throwing a rock in a pond. Okay, so we throw a rock in a pond, it ripples out. As it goes further away, what happens to those waves? They don't carry as much energy as they get out closer to the shore when you throw that rock in the pond. And then sound waves from stereo speakers spread out in spherical wave fronts. Think of if you've ever been across from a field from somebody, or you've been to a ball game and you're sitting way up in the nosebleeds at a big baseball park or something like that. And you can see the ball get hit, and then a split second later you hear the crack of a sound because those sound waves are not traveling very fast, but they are spreading out. That's why when you stand close to somebody or you're far away from somebody, you put your hands together when you scream. That way the sound doesn't leave and go straight this way and go out when I talk, but yet it goes this way. You might be able to tell the difference on the video in my voice. I can tell the difference when my hands are here and I'm talking versus when I'm here when I'm talking, just by hearing myself in this classroom by myself. So it may make a difference there with those sound waves. So, these are just some of the different forms of waves. We talked about vibrations. When an object vibrates back and forth at a regular rate, simple harmonic motion occurs. Think about a guitar. Nothing but vibrations on that string that's making that music. A vibration that fades out as energy is transferred from one object to another is called a damped harmonic motion. Transverse and longitudinal waves. Transverse waves cause the particles of the medium to vibrate perpendicular to the direction that the wave travels. And we will look at some of these different types of waves next week, and we'll draw some stuff and we'll have some math that goes along with it. So the transverse waves are perpendicular to the direction that the wave is traveling. A longitudinal wave, obviously, if transverse is perpendicular, longitudinal is going to be parallel. So longitudinal waves cause the particles of the medium to vibrate parallel to the direction that that wave travels. So we'll look at what are some different transverse and some longitudinal waves. Surface waves cause particles to move in circles. Shock absorbers, we talked about that. Why are they important? Springs absorb energy. So think about different springs. You have springs on your car when you're going down the road. You hit a bump, all right? It doesn't harm your body. It doesn't jar you as bad because the springs are going to absorb that energy. We have different things that we see where springs are located. They prolong the vibrations and they absorb and dampen those vibrations. Shock absorbers do. Go on to the next one. Shock absorbers and springs help keep the wheels of an automobile in contact with the pavement. So when you do hit a bump, okay, boom, and it hits, your car comes right back down. It doesn't stay up in the air. It doesn't make you create a wheelie as if you were going down the road in your car because of that shock absorber, because it's absorbing all of that energy from the road. Okay, so our summary here, a wave is a disturbance that carries energy through a medium or through space. Mechanical waves require a medium through which to travel. And light waves are called electromagnetic waves. They do not require a medium. And particles in a medium may vibrate perpendicular to or parallel to the direction that a wave is traveling. So, you're going to have some questions that go along with this that kind of just cover the different types of waves. Sound waves, light waves, infrared waves, microwaves, the electromagnetic spectrum that goes along with it. I want you to complete that work. Make sure you're still getting it turned in. I had the majority of you guys, probably half of you guys, do the work last week. Let's try to get that up a little bit. You will have, let's see, today's the 13th. You will have a Zoom meeting on the 15th from 9:20 to 10:05. I had very few people come on the Zoom meeting last week, so what I'm doing with those Zoom meetings this week, I'm combining classes. Your class will be on there with environmental science. If you can come on, if you have any questions with how things are going, what we're doing, if you just want to stop in and talk, then come on to the Zoom meeting, but the meeting will begin at 9:20. At 9:20, say the meeting only takes 20 minutes. If nobody else is on there, I'm going to end the meeting instead of just sitting there wasting time, because a lot of people didn't come last week. So make sure you are on time to that meeting. If you have any questions, like I said, you can email me or you can get on the Zoom. But other than that, I hope you guys stay healthy and can't wait to see you soon.